Okay, guys, so welcome to part 2 of your video notes for volcanoes. So our first topic today is our different types of volcanoes. We're going to have 3 of them. First one is a shield volcano. So think about looking at a shield from the side and how it has that bend in it, but it's not super steep, right? It's like this nice gradual curve that it has to it. And that's what we want to think of when we think of a shield volcano. So it's really broad, it's shaped like a dome, and it's going to be formed from just layers and layers of lava flows. These lava flows are basaltic, and so like we learned in our last video, we know that when we have basaltic lava flows, those are going to be the ones that will flow more easily or have that pahoehoe flow that we learned about. They're frequently going to cause our island volcanoes. And like I said, it's mostly pahoehoe flows. These lava flows can create this conduit system of lava tubes from the shield volcanoes. So you can see there that's a picture of me standing in a lava tube. That was on the Galapagos Islands. We didn't get to spend very much time there, but I did want to take a quick picture because I know that when we are trying to envision lava tubes, it may not necessarily click unless we have a picture. So there's a picture of me in a lava tube. All right, so our shield volcanoes then, again, this really broad shape to it, not very tall, just kind of almost like a wide volcano. So we're going to get all of these lava flows that are going to create our shield volcano. So not any like large eruption, really, just like these slow lava flows over a longer amount of time. Next up, we have our cinder cone volcanoes. So these are just kind of like the opposite of a shield volcano. So they're a lot smaller. They are a lot steeper. And instead of being made of layers and layers of lava flows, they're made of layers of those pyroclastic materials we learned about in our last video. So again, those are things like ash, and then any of that rock that gets ejected from the volcano. And again, they're going to be very steep. And instead of being these like ongoing layers of lava flows like we had in our shield volcano, these are only going to erupt once. Now, granted, that eruption could last a long time, but they'll only erupt once and then it doesn't erupt again. So here's our picture here. Again, much steeper on the side. And we've got, instead of layers of lava flows, we have these layers of pyroclastic materials like ash, lapilli blocks, and bombs that we learned about before. All right, and then lastly, we have the composite volcano, also known as a stratovolcano. So we know that strata means layers. So we had layers in the other volcanoes as well, but they were strictly layers of lava flows for shield volcanoes and strictly layers of pyroclastic materials for our cinder cone volcanoes. With a composite volcano, we're talking about alternating our layers. So we're going to have both. So we've got like some lava flow, some pyroclastic materials, some lava flow, some pyroclastic materials. So that's why we call it a composite volcano. We're kind of putting the two together. So we find these often in our ring of fire, which we know is around our Pacific Ocean, also called the Circum-Pacific Belt. And the magma is going to be andesitic in composition, so kind of in the middle between very viscous and not so viscous, but it's going to have a lot of gases, which we know can become problematic because with them being under high pressure, we can dissolve a lot of them, and then with lower pressure, the gas can then leave and be released in an eruption. So with composite volcanoes, we have these new problems that we didn't necessarily have with our other volcanoes. So they're both problems that occur with what's actually coming down the side of the volcano, and it doesn't have anything to do with lava like we may stereotypically think of when we think of volcanoes. So the first one is called the Nue Ardente, and that is a fancy way of saying glowing avalanche. So this is a glowing avalanche because it has those gases that were released mixed with the ash, which actually ends up being, like it says, glowing, along with rock fragments. So we kind of get this flow of pyroclastic materials that can come down the side very quickly and obviously be harmful or deadly to the people who are around. And then our other one is lahar, which we heard about in our Deadliest Volcanoes movie, which is a fancy way of saying a mud flow, but instead of it just being mud, this is a combination of, again, those pyroclastic materials, like our ash and lapilli blocks and bombs mixing with the water, and then it can come down very quickly. So just a refresher on our three types. So your shield volcano is, again, not very steep at all. And it's got like these lava flows that are coming out in these lava tubes. Next, we had our cinder volcano, which we said was smaller, but also much steeper. And we're going to have more of your kind of classic volcanic eruption in this case, instead of these several lava tubes. But in this case, we're going to get a lot of those pyroclastic materials coming out. And then with our composite volcano, we're alternating our layers of lava flows and pyroclastic materials to create a very large volcano that is, maybe not quite as steep as a cinder cone volcano, but is definitely very large. And then our last topic is to talk about what occurs with these igneous formations within the earth. So we've talked about what happens extrusively, so on Earth's surface. So now we're talking about what's happening beneath Earth's surface. All right, so these structures have a couple of names. So first, you can call them intrusive igneous formations, like you have at the top there. Another word for that is called a pluton. So plutons are basically like these segments of magma that are going to still be underground, and we're going to give them their names based on their shape. So our choices for that are either tabular or massive. Massive literally means probably what you're thinking. Massive means like huge. Tabular is a smaller pluton. And then we're also looking at how they're oriented compared to the other layers of bedrock. So if they are in line with the current layers or strata, we're going to call those concordant. And if they are able to cut across the bedrock, so if my layers are, horizontal and nice and flat like this, which they're not always, but if they were like this, then my discordant pluton is going to be able to cut across those layers and doesn't have to be in line with those original layers or strata. So we're going to have 4 main types of plutons. The first one is called a dike. So it's going to be tabular, so not massive, right? Not very big comparatively, but it's going to also be discordant. So it's going to be able to cut across any of those existing layers. And then kind of our sibling to a dike is called a sill. So it's also tabular, so not very big, but it's going to be concordant. So it will be in line with those original layers. So now we're into our next section. These ones are the massive ones. These are the ones that are bigger. So if it's massive, but also concordant, so in line with those layers, we call that a laccolith. So what happens with those is they kind of come up and they sneak in between the layers and they form like this bulge of layers on the top that we'll see in the next slide. And then a batholith is also massive, very massive. We'll see that in our picture as well. And it will be discordant. It is not going to stay within those layers. It's going to be able to cut across those layers. If we have a smaller batholith, then we call that a stock. All right, so in this picture, we've got our different types of plutons. So first up, we'll start with our tabular family. So these ones are the smaller ones here. So a sill is going to be in line with our previous layers. We call that concordant, and because it's small, we call it tabular. So if it's tabular and concordant, called a sill. As we can see here, this is a dike, so again, small, but it is discordant because it's cutting across the layers. It's not just staying in line. So it's tabular and discordant, so that's what classifies it as a dike. Our laccolith, shown in green here, is larger than our sills and dikes, so it is massive, but we consider it to be concordant because it came up under this layer here, and then as it got bigger, it's just making the layers on top kind of bulge upward and form a dome. So that is a laccolith, massive and concordant. And then our batholith, which I started to color in here in black, you can see is huge, right? So massive, definitely. And then also it's discordant because it's cutting through whatever layers it wants down here. It's not just staying in line. And then, like we said, if we have a smaller batholith, so still massive, still discordant, cutting through the layers, then we call that a stock. And that finishes up our volcanoes notes. Thanks for listening.